All right, fine. This one, you can see it's already factorized, but that one I can skip now. I think you know how to do that one, correct?
Yes.
And the next one, it's already in a thing. All you need to do is to transpose that 2 to become a minus, meaning you'll have minus 2 equals to 0. And then you will use a quadratic formula, correct?
Yes.
All right, so those two are taken care of because they're not bad. I want to deal with this because it is inequalities. Most people, they don't like inequalities. So what I'm going to do is I'm going to take the 6x squared, I'm going to bring it over. I know it's going to be negative. So it's going to be negative 6x squared and then plus the 5x and then plus the 4. The way the sign is, it stays as it is. So it's greater than 0. Now, there are 4 ways to change the inequality sign, but I'm going to give you 3. One, if you multiply or divide by a negative throughout, meaning left-hand side and right-hand side, you're dividing and multiplying by the negative. The inequality sign will face the other direction. That's number 1, but I just put them together. The next thing, number 2, if you flip, you reciprocate, you write the left-hand side and the right-hand side upside down, you reciprocate or invert both sides, left and right, the inequality sign will change. Okay, you don't normally do it you yourself, don't worry. The third one is when you're dealing with bases which are between 0 and 1, the base, when you're dealing with exponents and logarithm, the inequality sign will face the other direction. All right, just remember when you multiply or divide by negative, that's all you need. You reverse the inequality sign. So I'm going to change the sign of that one. So when we change the sign, we now have positive 6x squared minus the 5x and then minus the 4, then it's going to be less than 0. There we go. Now we need to factorize. When I look at the marks, it's 4 marks. It looks like we don't need quadratic formula. So we can actually factorize that equation. So what I do not enjoy with this is because when it's 6 here, I can work with 6 and 1. I can work with 3 and 2. Normally, I quickly go to the quadratic formula. But anyway, let's try it. Normally, I try as it is. Let's try it as 6x in the brackets. And then we go try 1x. Let's see if it works. If it doesn't work, we'll try the next one, the black one, meaning we'll try 3x because we're looking at the factors of 6, and we'll try the 2x, and then it will be less than the 0 like that. All right, let's see. Factors of 4, it's 1 and 4 or 2 and 2. Let me start with 2 and 2, which are easy. If I put 2 and 2 here, because I don't have to swap them, if I put 2 and 2, that times that gives me the 12, and then this one gives me the 2. So if I add 12 and 2, I don't get 5. If I take 12 minus 2, I don't get the 5. So then I say, okay, 2 and 2 won't work. Then maybe it's 1 and 4. But I'm going to try 2 and 2 in the next one as well, immediately, because it's easy to get rid of that one. When I multiply that, I get 6x. When I multiply this one, I get 4x. So let's see. 6 plus 4, it's 10. I don't get the middle term. 6 minus 4, it's 2. I don't get the middle term. So that one is out. So now we know 2 and 2 won't work. Now we need to try 1 and 4. So maybe I put a 4 here, and maybe I put a 1. Or maybe I need to switch them all around. First, I don't want to switch them. Let me put them as 4 and 4 for both cases. Let's see. Let's start here. If I multiply that with that, I get a 6x. 4 and 1, that one is a 4x. So when I add, it's 10. When I subtract, I get a 1. So it won't work, that one. Let's try it on the next one. 4 and 1. That and that will give me 3x, and then that one will give me 8x. There we go. When I add, I get 11. 8 minus 3, it's 5. Bingo. So this one looks like it's the one that's going to work. Now, in case maybe you are doubting, maybe your mind is saying, what would have happened if we place 1 here? And then we place a 4 there. Let's just check it. Because you're having 6 times 4 is 24. And then the other one will be 1. So when you add is 25, when you subtract is 20, so you don't get that one. So sure enough, you can tell that one won't win. The winning one is this one here. So I'm going to keep that mess as it is. So here's how it goes now. Since I know I've got a negative here, the term that looks bigger between 3x and that one must get a negative. How did I get the 8? Using that 4. So the negative comes here, and then the plus goes there. So now we're good. Now we're good. So like I said, if you pretend this as equal sign, no problem. You can solve for x. So let's write CV, critical values. Come on, let's use a math. You transpose the 4. It becomes 4 divided by 3. So you're having 4 divided by the 3. And then the other one, when it transposes, a negative 1 divided by 2. So the next number is going to be negative 1 over the 2. All right, just solve for x. That's what I'm saying. All right, then you want to draw a number line because you guys, you're the number line guys. Then I said, no problem, there's a number line. After the number line, then you're like, okay, what kind of a parabola is this? Because when you look here, that times that, it's a positive x squared. Actually, you can see it here, positive 6x. So that means it's a smiley one. So there it is. It goes like that, smiley face. You look at the number. This one is really a negative. Negative goes to the left. It comes where it comes here. Negative half is there. And then the other side will be 4/3. All right. Now, since there was no equal sign, I already know that the thingy must have an open circle, the open circle. Let's read the sign. The sign says less than or below. So which part is below? It's actually this one, the bluish one. Down here, it's between half and 4/3. So that means x must be between. So you just put your minus 1 over the 2, you write less than x and then less than 4/3. So that becomes your answer. Whenever it's between, the answer is like that. Smaller number on the left, bigger one on the right. I hope it's making sense. Is it making sense to you, dear friend?
Yes.
All right, here comes the exponent one.